So Parametrics Day 2. This is the second day of our lesson on creating equations with a third parameter, specifically time. But these problems that we're working today are going to involve projectile motion, right? You standing at a specific point, you throw a ball, you want to see how far it travels away from you, how long it takes to get back to the ground or wherever, and how high it's going to go. So it's still parametric. We're still dealing with x and y in terms of time. But in these particular problems, we're not going to be creating parametrics through a linear vector equation. So we're going to be working with all of our parametric equations for projectile motion, dealing with these two basic equations. And so the x value, or the horizontal distance that the object travels, the horizontal distance that the object traveled is found by doing v sub 0, which means initial velocity, okay, that's the speed at which you throw it, times the cosine of the angle. And the angle, look at our picture right here, the angle is the angle that the object makes with horizontal, not with the ground, not with the y-axis, but with horizontal to the ground, okay? So it's the angle that the object makes to horizontal. That's our angle theta. And then times t for time. And our vertical is a much more complicated equation. And this equation has to do with gravity. You've seen this in physics if you take a physics class. And the vertical equation is -1/2 times g, which is the variable for gravity, times t squared, plus the initial value times the sine of the angle, all times t, plus the initial height at which it was thrown. Now, some equations, some books will say height equals, and they'll call this height 0. But what you need to remember here is that v sub 0 is your initial velocity, theta is your angle to horizontal, and h is your initial height. Okay, the height at which it leaves the ground. Let's take a look at a specific problem. Also, if you are working with a problem that mentions feet per second, you use the number 32 for gravity. If you're working with a problem that's meters per second squared, or mentions meters, you're going to use 9.8 meters per second squared for gravity. So when we look at this problem, it says a baseball is hit with an initial velocity. That's our v sub 0, our initial velocity of 70 feet per second. So right now I'm going to go ahead and write down g equals 32 feet per second squared. And an angle of 50 degrees. And they mean, of course, from horizontal. If the ball is hit at an initial height of 2.5 feet, that's our h. Find the parametric equations that represent the baseball's position. Well, the horizontal position of the baseball, that means how far away it is from you, is going to be found by doing initial velocity times the cosine of theta, all times t, okay? All times t. Our initial velocity was 70, our angle was 50 degrees, and our time, we don't know. So there's our variable. So now we have 70 times the cosine of 50 degrees times time. Please notice that this is in degrees, not in radians. Our vertical equation is going to be -1/2 times, we're going to use 32 times t squared, plus initial velocity times sine of theta. All right, our initial velocity was 70 times the sine of 50 degrees, all times t, plus our initial height, which was 2.5. So these are our parametric equations. We've got 70 cosine of 50 times t, and I'm going to do a little simplifying here. This is -16 t squared plus 70 sine 50 t plus 2.5. Now, if I have a calculator, I'm going to absolutely be typing both of these in if I wanted to see the path of the ball as it travels over time. But the question they asked me was just, how long is it in the air? Well, how long is it in the air deals only with the vertical. How long is it in the air, not on the ground or below it if it falls into a great big chasm, right? So what they're asking is, when does the ball hit the ground again? So think about the picture. You've got starting at 2.5 feet, it's flying over here. When does it hit the ground? And the ground is whenever y equals 0. So if I set this equation equal to 0, so in other words, if I came back up here and I said, all right, 0 equals that whole equation. Well, if you want to, you can use the quadratic formula, plug in x equals negative b, and so forth. But that's a lot of work there. What if I just go back to function on my graphing calculator? Let's go back to the mode. Make sure that we are in degrees because it's 50 degrees, and I went back to function. Now the equation that I typed in two equations. I typed in the first one, negative 16x squared plus 70 sine of 50x plus 2.5. There's my y equation. And then I set it equal to 0. When graphing it, you see the parabola. I'm going to zoom my window a little bit bigger. I want to see how high it actually goes. Let's set our window to go from negative 10 to 50. The ball may actually go 50 feet in the air. We'll see. Now let's watch it. We're going to watch the path. We really didn't need it. There it goes, and there it falls. They want to know where this is. It's also now, there's my y equals 0. And how do I find where the curve equaled the line? Well, second, calculate the intersection of the first equation. See, it says first curve. There's the first equation, enter. The second equation, 0. So where does the curve equal 0? It says, do you want me to take a guess? No, that's why I paid $100 for you. And the intersection it gave me was right back there at 0, but I wanted this one. So what do I need to do? Second, calculate the intersection. And I'm going to move this over closer to the other intersection. Okay? And it says first equation, yes. Second equation, yes. Do you want me to guess? No, still don't. Equals, push enter. And it happens at 3.39 seconds. This ball is going to remain in the air. The time value is 3.39 seconds. That's how long it's going to remain in the air. Then the next question said, all right, how far away is that? Where did it land? When did it reach a value of 0? Meaning that the time we're going to use is 3.39 seconds. Let's plug that back into our horizontal equation. Our x value is going to equal 70 times the cosine of 50 times 3.39 seconds. So let's pick up our calculator, go to the home screen, 70 cosine of 50 times 3.39 seconds, and the ball was in the air, the ball landed 152.5 feet away from the thrower. Now our second problem is a little bit more complicated because of what it's asking, but we'll get to that in a second. The first part is exactly the same. We're going to use x is equal to initial velocity cosine theta times t, and y is equal to negative 1/2 gt squared plus initial velocity sine of theta times t plus our initial height. So we've got the same formulas. So I've got a shot putter, throws a shot put with an initial velocity of 30 feet per second. There's my v sub 0. At an angle of 40 degrees, there's my theta. At an initial height of 6 feet, there's my h. How far will the shot put travel before it hits the ground? Okay, so this is one that we're going to set our equation equal to 0 to find our time. We're going to find our time using our vertical equation. And then we're going to plug into our horizontal equation to find how far. So this is actually both parts of the last one in one. So how far? We've got feet per second, so we know we're going to use 32, and negative 1/2 of 32 is negative 16 t squared, plus initial velocity was 30 feet per second times the sine of 40 degrees times t, plus our initial height. I'm going to go back to my graphing calculator, go to y equals, and type in that equation. Negative 16 t squared, or x squared, plus 30 sine of 40, close my parentheses, x, plus 6. Once again, I want to know when it hits the ground. So I'm setting y equals to 0, and I go. Let's see our graph coming up. There it is. I want to find that one right there, that second one. So second, calculate the intersection. I'm going to move it closer to that second intersection right there. Enter, enter, enter. And it happened at 1.66 seconds. So my time is 1.66 seconds. We're going to plug that into our equation, which was initial velocity, 30, times the cosine of our angle, 40, all times 1.66 seconds. On the home screen, 30 cosine of 40, close parentheses, times 1.66 seconds. Okay? Oh, managed to take that away completely. 30 cosine of 40 times 1.66 seconds. And the ball landed 38.149 feet, or the shot put landed 38.149 feet away from me. So I've got a guy standing out there. He's 6 feet tall. He's standing out there 25 feet away from me. And the question is, will the shot put hit him? Okay, he may be an idiot standing out there in front of me, but I know that if he's 25 feet away in the path of the shot put, I threw it 38 feet. It went past him, or it hit him. I want to know if it hit him, and if not, by how much would it miss him? Did it go over his head, or what? So let's take a look. In this equation, I've got 25 is his distance away. And I'm going to set that, so that's his horizontal distance from me. So I'm using the horizontal equation. 30 cosine of 40t. Well, I'm going to solve for the letter t. So I'm going to divide by 30. So that's 25 30ths equals the cosine of 40t. Or, let's actually, and then divide by cosine of 40. Or if I'd have been thinking, couldn't I have just divided by 30 cosine of 40? So 25 divided by 30 cosine of 40 equals t. So on my blank screen, I'm going to take 25 divided by parentheses 30 cosine of 40, because I want to make sure it does all of that. And it was 1.088 seconds. So time was equal to 1.088 seconds. Now that's when it's going to reach the 25 foot away from me mark. But how high is it going to be? So I'm going to take that and I'm going to plug it into the vertical equation. And that's going to be negative 16 t squared, so that's 1.088 squared, plus 30 sine of 40 times 1.088 plus 6. So that was my original equation. I just plugged in 1.088 where the time was in both places. Go to my calculator. Negative 16, let me clear that out. Negative 16 times 1.088 all squared plus 3 sine of 40 times 1.088 plus 6. Somehow I've typed in something wrong. Give me just a second. Well, I'm back. Let's go back and look at our paper. See my mistake right here? What was my initial velocity? It wasn't 3, it was 30. So sometimes you have to go back and look and see what your mistakes are. And I have to copy that equation again and change that to a 30. I knew it didn't make sense because the answer I got was that it was 25 feet below the ground. I know it wasn't below the ground because it was still traveling. So let me insert my 0 right there, make this 30. And the shot put at that specific location where he was standing was 8.041 feet above the ground. He was 6 feet tall, so the shot put sailed 2.01 feet over his head. We'll pick up solving for parametric equations, which is eliminating the parameter, in the next video.